So the final part for Unit 1 that I kind of want to go over is starting to explore, and again this is just the beginning, an exploration of a relationship between two different variables. So everything we've done so far, the central location, mean, median, mode, the dispersion, range, standard deviation, variance, interquartile range, that's all for a single variable, a single column. A lot of times, however, we're really interested in relationships between more than one column, more than one variable. So we're looking for some kind of association between the two. So to do that, a good first step is to actually visualize the data, which we're going to do a lot in Unit 2, but this is a good transition over to Unit 2. So if there's a possible relationship between the two variables that we think exist, we should plot or graph the data. So the question then becomes, what type of chart or graph or plot do you want to use? So we haven't gone over any of this yet, so you probably are familiar with some types of charting techniques from your BUS 195 or AB 190, the Excel class that is a prereq to this one. So then really the big thing is when we plot the data, we're looking for patterns. And here we're looking for some kind of association between two variables. So when we do this, we usually often think, is one variable causing another variable to happen, or is one the result of another one occurring? So to do this, the best kind of plot to do for association between two variables is a scatter plot, an XY scatter plot. So the independent variable, the X, goes on the horizontal axis. The thing that we think is a result of X happening, the independent variable happening, goes on the Y variable, on the Y axis, the vertical axis. So in order to do this, we're going to plot the data, and then we want to look at some other statistics for it. So let's go over to the data set before we start to get into the statistics part and see if we can plot the data. Let's find two variables that we think are somewhat interesting. So we've been looking at calories the whole time, right? So if we think that if we're concerned about the number of calories in 12 ounces of beer, then we might want to think about the things that is driving the calories to go up. So there's not a whole lot to beer. There's water, right? Alcohol, and then the carbohydrates and all that stuff. There's nothing else. There's nothing. It's very few things that go into it. So the calories can only be derived from alcohol and carbohydrates and any kind of extra stuff that might be thrown in. So it might be a good idea to let's try to plot the alcohol by volume content to the calories and see what it looks like. So here we think that alcohol is causing more calories. So the higher the alcohol content, the more calories in 12 ounces of beer. So that means our independent, our X variable, would be the alcohol, column C, and the Y variable, the outcome, result, would be in column D. So to do this, let's go, and I'm just going to go to Insert, and under Charts, pick the one that looks like dots, Insert Scatter, right? And I just want plain scatter, and it tries to pick everything for me right here, right? Which I don't like. So what I'm going to do is I'm going to come over here and try it again, and it still doesn't like it. So maybe what I'll try to do is just select column C and D, but I don't want all that stuff at the bottom of D. So let's try this, right? And then let's try Insert Scatter, and I can't see what it looks like. It's all the way up here. Alright, so again, it's still got stuff in there that's no fun. Alright, so that's fine. Let's do this. I'm going to move this. Let's select the data first. So I'm just going to remove everything. Then I'm going to add the X values are going to be in column C. And I'm not going to do that last one with the little dot star there. I think that might mess us up. And why did it only go to 154? I want C2 to C176, and this I want D2 to D176, and that's looking more like what I like. All right, and click OK, click OK, and then I'm going to move this over to its own worksheet, just so it's not on top of that. All right, and then as we'll learn in the next chapter, I don't like any of this grid line crap. All right, so we have an XY scatter plot. All right, so it's saying the percentage as percentage of alcohol, which is on the x-axis, the calories are over here, right? So we should probably label stuff to make it a little bit better, but I'm kind of lazy right now, so I'm not going to do that. So it looks like, yes, there is some kind of relationship, and it looks like as the percentage of alcohol goes up, calories go up. Again, that shouldn't surprise us. There's nothing groundbreaking here. Alcohol contains calories, right? So if you want to cut out calories, cut out drinking. Of course, that's not that much fun sometimes. Not only that, but it also kind of looks like it's somewhat linear, right? Yeah, so there are some, most of these kind of fall along some kind of similar pattern, right? This one right here looks a little bit interesting. That's the Bud Light Select 55, Bud Select 55, right? And, there's some stuff we could talk about for that. We're not going to. But so we can see that there does appear to be an association between those variables, and it appears to be somewhat linear and somewhat upward for linear, right? So because we have that, that's a good thing, because we can actually measure that linear relationship between two variables, and the x and y pairing is vitally important. We're going to use covariance. It's the name of the statistic that we're going to calculate. So what I mean by the pairing of x and y being vitally important is I couldn't take the alcohol content from Bud Select 55 and match it with the calorie content on the Flying Dog breweries that had like 300 calories in it, right? That's not right. They have to stay together. The one bad thing about covariance is that the magnitude of the resulting statistic does not necessarily mean that there's a stronger linear relationship. So just because it's larger doesn't mean that it's a stronger linear relationship. This is because covariance is highly, highly dependent upon the units used for measuring the variables. Right? So let's calculate covariance between our X, which was our alcohol content by volume, and our calories. Right? So we're going to use, it's a sample covariance, so covariance.s. So let's go back over and come back to sheet 1, which I haven't renamed yet. And let's do sample covariance. And this again is covariance, if I could type today, variance.s. And the alcohol is in column C, so C2 through C177. I'm going to do all of them and see what happens. I know there's junk in there, so let's see if Excel is smart enough to get rid of that junk for me. D2 through D177. And we see the sample covariance is 0.5389 ... Right? So again, without having something else to compare it to, we can't say a whole lot about the strength of the relationship. So, for example, a calorie, when we talk about food, is actually a kilocalorie. So if this was measured instead, right, so these are measured in kilocalories, not calories. So a kilocalorie contains 1,000 small calories. So you can look all this stuff up, right, if you're into that food stuff. So, for example, if I know that there's 1,000 calories, small calories, into 1 kilocalorie, I can multiply it by 1,000, and that's how many small calories there are. All right, so then if I do it all the way down, then I get a bunch of small calories. I'm going to get rid of this one and this one because that doesn't look like it's going to, well, let's not. Let's see what happens when I try to do it. So I'm going to copy this guy down, and where did I put that? I put it in H. So instead of D, I want to put H and H. And it says not a value because of this guy here. And then 0, really, no beer has 0 calories, unfortunately. So we do that, and we see the sample covariance went up, right? It moved it over 3 decimal places to the right. That shouldn't surprise us, right? Because we just changed the units to small calories instead of kilocalories. So sample covariance using small calories. Now, the relationship between alcohol content and calories didn't change at all. However, our statistic, our metric did, because we used different units for the calories. So that's one of the drawbacks of covariance. So to combat that, we have a different statistic called the correlation coefficient. So it, again, measures the linear relationship between two variables, and it's not affected by the units of measurement of the variables. It always falls between -1 and +1 inclusively. So the interpretation is, near 0, there's no linear relationship. Near -1, it's a strong negative relationship. Near +1, it's a strong positive relationship. Then you have to be careful using correlation coefficient because it only describes the strength of linear relationships. So there could be a very easily discernible non-linear relationship and still come up with a correlation coefficient of 0 because it's not linear. But there could be some kind of relationship that is interesting. Hence, we should probably plot the data, which again I'll hammer into your head in the next unit. So to get this, we do the sample, we do correlation, cell range for X, cell range for Y. So let's go back over to our data set and try that. So here's correlation using, let's do kilocalories first, and let's see if it changes when I use the small calories. Right? So this is correlation, and we're in C2 through C177, and D2 for the calories through D177. So the correlation coefficient between the data as it was given to us was 0.905. That's a really pretty strong positive linear relationship between the alcohol content and the calories. Again, we saw that in the plot over here in this chart, in the scatter plot. So that reaffirms or confirms what we were thinking, that there is a strong linear relationship between the two. Right? So what happens if instead I change it to the small calories? So now I'm pointing over to H2 through H177, and we get the same correlation coefficient. So that's the nice thing about the correlation coefficient, right? The relationship is still the same between alcohol and calories, no matter how we measure calories. So we measured one time in kilocalories, one time in small calories. The relationship stays the same, which is what the correlation coefficient is telling us. The covariance one, right, it's much harder to interpret the magnitude, right, the value of this. This, however, is much, much better for interpreting the linear relationship, strength of the linear relationship between the two variables. Now, the other thing you have to remember, too, one other quirk of correlation is that it actually doesn't matter which order I put the X's and Y's in, because correlation does not mean causation. as you should have learned in the linear regression part of your statistics course. So now I'm putting calories correlated with alcohol. It's the same number that I got over here. And if I want to see what I did, right, I can show the formulas. So here I put alcohol, then alcohol, then calories. Here I put calories, then alcohol. And we got the same correlation coefficient of 0.905. So strong linear relationship between the two. So even though I get the same correlation coefficient regardless of which one I think is up, X and Y, it's vitally important that you in your own head know which one you think is the outcome variable, the Y. So again, I think calories is what we're trying to figure out where they're coming from. So the independent variable, the X, is the alcohol part. Okay. All right, so that finishes up Unit 1, Descriptive Statistics. Next unit, we'll move on to visualization. So more charting and plotting and all that fun stuff.